Hi, my name is Lily Regan. I'm recording this on 11/10/2025, and here is my presentation on L-DOPA. So L-DOPA is the common name. Levodopa is also a common name for it. The IUPAC name is 2S2-amino-3,3,4-dihydroxyphenylpropanoic acid. The intended use for L-DOPA is as a medication used to treat the motor symptoms of Parkinson's disease, which are characterized by slow movements, tremors, and stiffness. Parkinson's is caused by a lack of dopamine in the brain. Dopamine itself cannot cross the blood-brain barrier, but L-DOPA, which is a precursor to dopamine, can cross that blood-brain barrier. Once it gets inside the brain, the L-DOPA will then convert to dopamine, which can then help improve motor function in those ways like that slow movement, stiffness, and all that. We have a couple of functional groups in L-DOPA. We have this carboxylic acid over here. It's the carbon double bonded to the oxygen, and that carbon's also bonded to an OH group. We then also have a primary amine here. We have the NH2, and we'll talk about this carbon right here in a little bit. We also have two hydroxyl groups, but because they're attached to an aromatic ring, this is actually called a catechol. It's its own functional group. L-DOPA is a chiral drug. That carbon that we were talking about earlier is actually that chiral center where that star is. It's attached to 4 different groups. There's a hydrogen that's hiding in the back going into the page. And then we assign number, like priority number, based on atomic number. So we're going to have that NH2 in that first priority group. That carboxylic acid carbon is going to be the second priority group, and then the third will be this other carbon on the left that's attached to here. Then we have that hydrogen in the back. That'll be the fourth priority group. And because we're already arranged in a way that the hydrogen's going into the page, we're in the right form, and we're going to be going 1 to 2 to 3, which is counterclockwise. I always think of counterclockwise as left or the devil, and then I think of like sinister, which is actually kind of where the S name came from. So that's going to be the S form, which is actually the S enantiomer. We also have another isomer of an isomer of L-DOPA, which is the enantiomer. It's the D-DOPA. It's going to be also flipping around right where that chiral center is. These are mirror images of each other. They're non-superimposable. They are different compounds. They have different physiological effects. The L-DOPA is the active form. The D-DOPA is actually the inactive form and actually can hinder the activity of L-DOPA. And D-DOPA is that 2R enantiomer, 2R, 2-amino-3,3,4 dihydroxyphenylpropanoic acid. There are no diastereomers of L-DOPA because there's only one chiral center, and these guys are mirror images of each other. There could potentially be some constitutional isomers based on these hydroxyl groups, like they could move around this ring. However, that doesn't happen naturally. It would have to happen like if maybe it was under oxidative stress or synthetically. And here are my references. Thank you.